Tonight's video is a continuation of Section 7 of our Chapter 7 notes. We're starting on page 13 of our notes packet. You want to have your graphing calculator handy with you when taking notes on this section. The number E. This number has an important role in many different branches of mathematics. A calculator will give you the value of E to 9 decimal places. Now, where do we find E on the calculator? On the left-hand side, the LN button, just above it in blue, is E to the X. So if we want to compute E, we would do the blue second button, E to the X, and then we would press the number 1. So E to the first power, and enter. And that yields that decimal. But E is an irrational number. The above pattern does not continue to repeat. 18th century mathematicians computed this number to many decimal places and assigned to it the symbol E. Just as earlier mathematicians computed to many decimal places the ratio of the length of the circumference of a circle to the length of the diameter and assigned the symbol pi to this ratio. So the number E is an irrational number, just like our number pi is an irrational number. For the next example, we want to find to the nearest hundredth the value of 1 plus E to the second. So we use our calculator, pressing 1 plus second E to the X, and then the number 2 for our exponent. 8.3890560099. Rounding the answer to nearest hundredth. Remember our decimal places. The 3 is the tenths place, the 8 would be the hundredths, the 9 would be the thousands, 10,000s, 100,000s, and so on. The 8 is in the hundredths place. You look to the right. If it's 5 or greater, you round up, which this is 9, so the 8's going to round up to 9, yielding 8.39. rounded to the nearest hundredth. The next 3 problems ask you to do on your own to find the value of X to the nearest thousand. All right, thousandth is 3 decimal places. So if you want, pause the video and go to your calculator. Number 1, X equals E to the third plus 8. So just key it into the calculator. Second, E to the X. 3, make sure you arrow out of the exponent, plus 8. Enter. And the decimal is 28.08553692. I'll write out the whole decimal and then I'll round it. So I'll write the whole decimal beneath the line, 28.08553692. Tenths, hundredths, thousandths. So the first 5 here is in the thousands place. You look to the right, 5 or greater, you round up. So this is going to round up to 6. So our answer is 28.086. The next problem, we have 2x equals negative 8e squared. We'll get x by itself first, divide by 2, and we have x equals, negative 8 divided by 2 is negative 4, negative 4e squared. Let's go to the calculator. Negative 4 times e squared, or you can simply put second e to the x, 2, and enter. and that's negative 29.5562244. So this result is negative 29.5562244. Again, tenths, hundredths, thousands. The 6 is in the thousands place. You look to the right. If it's 5 or greater, you round up. This is not. 2 is not 5 or greater, so that stays a 6. So our answer here is negative 29.556. And the third one. And we want to solve for x to the nearest thousandth. Get x by itself. Divide both sides by e to the 5th. We have x equals e to the 4th divided by e to the 5th. We could key it into the calculator like that, or we could use our rules for exponents, and this would equal e to the negative 1, or 1 over e. Go to the calculator, I'm going to key in e to the negative 1. Second, e to the x, negative 1. Enter. There's our decimal result. I'll copy the whole thing down and then round to the nearest thousandth. So 0.36787944412. The 7 is in the thousands place. You look to the right. That's going to round up to 0.368. Next, page 14, going back to money and interest problems. Compound interest. When you deposit money in a bank account, most banks compound interest more than once a year. When this is the case, the amount of money you'll have after a certain amount of time is given by the formula A equals P times quantity 1 plus R over N raised to the NT, where A is the final amount of money, P is the initial amount, otherwise known as principal, R is the rate of interest as a decimal, usually given to you as a percentage, which you would have to change to a decimal. N is the number of times per year interest is compounded, and T is the time in years. So the example we have is for interest compounded quarterly. Joan invests $500 at a bank offering 3% compounded quarterly. So the 500, that's our P. That's our initial amount of money. That's P. The 3% is our rate. We'll have to change that percent to a decimal. And quarterly is the number of times per year. So quarterly meaning 4 times per year. So that's our N value. Find the amount of the investment at the end of 15 years if untouched. So 15 is our T value. So we take the formula A equals P times 1 plus R divided by N raised to the NT. And we substitute our values into the formula. So the final amount, A, would equal the initial amount, 500, times 1 plus 3% as a decimal is 0.03, divided by quarterly, our n value is 4, raised to the 4 times 15. And I would key this into the calculator exactly as it is there. All right, so that's 500. Clear that. 500, parentheses, 1 plus fraction, alpha y equals 0.03 divided by 4, arrow out of the fraction, close the parentheses, and raising it to the exponent of 4 times 15. I'll write down the entire decimal that appears on the calculator. $782.8405135. It doesn't mention any rounding, but we are talking dollars and cents, so the 4 would be in the cents position. Place, look to the right, and it stays. So $782.84 would be the ending amount after 15 years. Now, if compounding takes place without interruption, this is called compounded continuously. This formula from above becomes the following. A equals P e to the RT. So whenever anything is compounded continuously, you're using this formula. A again is the final amount of money, P is the initial amount, R is the rate of interest as a decimal. Another word for E is called the natural base. We'll look at that more closely in the next chapter, chapter 8. And T is the time in years. So even though this formula, we need to know this formula, so let's write it down. A equals PE raised to the RT. Now, it's just E that has the exponent RT, right? So an example using interest compounded continuously. Tamika invests $500 at a bank offering 3% compounded continuously. Right there, as soon as you see that, it involves E. A equals PE to the RT. Find the amount of the investment at the end of 15 years. So our initial investment, 500, that's our P value. The 3% is our R. We need to change that to a decimal. And we do so by simply taking the decimal point and moving it 2 places. That's 0.03. And T is 15, or time is 15 years. So now we take our formula, A equals PE to the RT, substitute our values in, 500, E raised to the 0.03 times 15. And again, I would go to the calculator and key it in just like this. $500, E, second, E to the X, 0.03 times 15. 784.1560927. rounding to the nearest cent, $784.16. And that finishes Chapter 7 notes.